Hello, everyone. Caresoft would like to welcome you to our Horizon 3 AI webinar. At this time, I would like to introduce our speakers for today, Sneha Antani, CEO and co-founder at Horizon 3 AI, and Patrick Coughlin, GVP of Security Market at Splunk. Sneha, the floor is all yours.
Excellent. Thank you. And for the team, I really appreciate your time in the audience. And it's great to reunite with my friends, brothers and sisters at Splunk. It's been a long time coming since I've done a joint webinar with the True. And Patrick, I'm really excited to do this with you. What we're going to talk about today, we're going to talk about security controls and helping you get more value out of Splunk and improving your security posture. We're going to do so through the context of telling war stories. So at Horizon 3, we do autonomous pen testing, and we've run nearly 10,000 pen tests over the past 2 years. And there are a ton of really interesting insights and stories from those pen tests. And I want to kind of share those with you and show what controls worked, what were some of the systemic problems, what are some just crazy what's going on here moments, and then use that to help defenders and blue teamers better understand where to focus their efforts. So I've really got 3 goals in this session. One is to help you as the audience understand how to get more value out of your existing Splunk investment. Right? I was the former Splunk CTO. I've spent over the last decade over $30 million on Splunk license. So I very much have been in the thick of it with the company for the past 10 years. And being able to make sure that you put that investment to great use is a set of experiences that I've spent a lot of time sorting through. The other part is understanding that don't focus on what's vulnerable, focus on what's exploitable. And the hardest part of the job when I was a CIO at financial services before was deciding what not to fix. So how do you focus on fixing problems that truly matter and using that to protect that limited precious time that your systems administrators, network engineers, and other fixers have in the organization? And then finally, to help you identify ways to find gaps in your security controls and your incident response processes. Everyone's got a plan until they get punched in the face, and you don't want to be learning about how to deal with an incident in the middle of the incident. So what can you do to proactively verify your people, your processes, so you build that muscle memory ahead of time? So those are the goals. I'm going to talk through this story, and please ask questions along the way. That way we can maintain context for what you're interested in diving into. So here's the reality. When I was a CIO, when I was on the road as a Splunk CTO, and my time serving within the Department of Defense, I would constantly be asked and ask my team, are we secure and how do we actually know? Are we logging the right data? Are we fixing the right vulnerabilities? Do our people know who's in charge of what decision during an incident? And if everything looks great in PowerPoint, awesome. But how do I actually know that's true? And this was really the mindset and experiences that every single blue team within my ownership or within my sphere of control at every job I've had went through. We would go off and spend a ton of money buying all of these security products. We checked the boxes that we got the products installed and configured, but we had no idea that the tools were actually working together to improve my defenses. And we had to wait for a breach to find out. And by then it was too late. And then what we'd do is use this to justify actually testing our environment. So then I'd get approval to go off and run a pen test. Step 1 is justifying the budget. Once we got the budget justified, then I'd engage a consulting shop and spend weeks internally preparing so that we'd look good. And now that we're ready to go, the pen test team would show up and just shred us apart. And they would absolutely own us 15 different ways, regardless of the preparation we put in place. And then we try to go off and fix all of those issues, but we didn't have the internal attack skills to verify that our fix actions were correct. And so oftentimes, this year's pen test results were identical to last year's results. And what you have here is an unsustainable loop where the red team is constantly embarrassing the blue team. The blue team is spending nights and weekends doing everything they can to protect their environment, but they simply don't know that they're ready to defend against a real attack until the bad guys have showed up. So from there, what I tried to do as a CIO is start to build up this continuous verification posture. And it started with layering in vulnerability scanners. But the problem with vuln scanners is being vulnerable doesn't mean you're exploitable. I might have 100,000 findings in Qualys, but maybe 10 are actually exploitable. And moreover, these vulnerability tools will only show you problems on a single machine. They don't chain together problems across multiple machines into a kill chain. Then I tried layering in consultants, but when you've got 5,000, 10,000, or 100,000 hosts in your environment, humans simply don't scale. And what you need to be able to do is use autonomous pen testing type techniques to test at scale, and then free up your humans' time to focus on the things that truly matter. So for example, being able to use, say, Horizon 3 to go test your infrastructure at scale, and then find all the juicy stuff and then tee up really high-end attackers from Bishop Fox or Mandiant or others to go very deep and probe deeply in specific areas. And that's what we see customers typically execute. And then finally, this idea of running simulations, but simulations often aren't safe to run against production and have many other shortcomings. And what I wanted to have in place and what compelled us to start Horizon 3 was this really fast cycle where we can run pen tests as often as we want and should only take a few hours to complete. Our blue team can immediately start fixing those issues and then very quickly rerun the pen test to verify that the problems have been fixed. And what we talk about is this find, fix, verify loop to help IT admins, network engineers, security admins, Splunk admins, and so on self-service verify their security posture. And we want to be able to do that without requiring agents be installed, custom attack scripts being developed, and also be safe to run against production, and the whole thing be self-service. So with that context of what we do and kind of the pain I had as a practitioner, what I wanted to share were 5 war stories. And the style we're going to take here is I'll talk through the war story, and then Patrick and I can talk through our observations of how we've seen this elsewhere. And once again, if you have any questions, please feel free to just drop them in the Q&A box, and then we'll get to it as soon as we can. Now, the first war story is that my EDR should have caught that. That's the punchline. This is an infrastructure pen test. This customer bank did everything they could the right way in installing an EDR. They had user behavior analytics products in place. They initiated an internal pen test against their infrastructure. And our product NodeZero discovers 5,000 hosts that are reachable from that network location. We automatically organize all that data into a cyber terrain map. And that cyber terrain map represents all the hosts, ports, services, credentials we've harvested, and so on. This customer had Fortinet installed to defend those hosts. So they, once again, done the right things. Yet Horizon 3 and NodeZero, our product, was able to get code execution on a machine. It then successfully dumped those credentials and then reused those credentials to log into the machine next door. And the customer was shocked that this happened because that code execution should have been detected by Fortinet and stopped by Fortinet. Yet it didn't. And so now the question is, what happened? The next issue is because we dumped credentials and successfully pivoted, Fortinet should have detected that credential pivot through their lateral movement algorithms. The reality is that of those 5,000 hosts, Fortinet was not installed correctly on 3 of them. And remember, defenders have to be right every single time. Attackers only have to be right once. So what happens is out of the three machines that were misconfigured, an attacker is going to be able to find them through their network reconnaissance. They're going to test to get code execution. And once they do, they're going to successfully dump credentials, reuse those credentials, and then laterally maneuver throughout the organization. So the question is, what do we do about it, right? Step 1 is making sure that we fix those misconfigs. Step 2 is to make sure that we're able to effectively detect that lateral movement. And then step 3 is making sure we understand who's logging in where with privileged credentials so that we've got additional auditing and monitoring. And so Patrick, maybe tee you up here on some of the best practices and observations you've seen in successfully deploying user behavior analytics to detect and stop that credential pivoting, being able to verify the security posture accordingly, and the role that you've seen Splunk kind of dominate in these types of use cases in detection.
Absolutely, Snail. Thanks for having me, folks. Really happy to be here. Real quick, just on my background and by way of introduction, I'm a security analyst by trade. I started my career as a researcher. If you go back far enough, looking at how bad guys were using the internet and some early online video games like Second Life, if anybody remembers that, for God's sakes. And then I moved into more of an operational role, actually originally focused on counterterrorism. I know, Snail, you spent some time with JSOC. I spent a fair amount of time at Fort Bragg myself, and really looking at using big data tools to track terrorist financing, look at terrorist group movements, primarily in the Afghan and Iraq war theaters. And then from there, I pivoted to more of a traditional cyber defense role where I built security operations teams for largely in Europe and the Middle East, North Africa, but then of course in America as well for public sector and private sector multinational corporations. And I think that the themes that you hit on here, Snehal, are top of mind for, I mean, certainly in my experience, but also for so many of our customers. What resonates with me is the challenges around integration debt and how often the lack of connectivity across teams and tools and data sources will lead to gaps in visibility that are easily exploitable by attackers, but really more often than not just create blind spots in the detection and response workflows that you are trying to mature as a security leader. I think the second thing that comes to mind is, you can have the best machine learning models in the world built into your UBA tools and into some of your other detection tools that are out there. But it's the health, it's often the table stakes capabilities around configuration that will create further gaps in your architecture. And so, we spend a lot of time at Splunk really preaching what I think is a very sober approach to machine learning, which is, let's make sure you've got the right models in the right places at the right time, but let's not let the nirvana of machine learning get in the way of the health and the hygiene of the program. And if you can detect, this kind of malicious behavior that you walk through here using machine learning models, you're doing fantastic. You're in the top 10% of sophistication when we look across our 15,000 customer base. But also, we see so often that you can't actually. You may be able to do that, but you can't detect on a known bad indicator in your SIM and your EDR that's been published and verified as known, and you don't have automation in place to orchestrate the resolution of that incident. And so I think best practices that we preach all the time are one, be mindful of your integration debt. The promise of things like XDR, I think, are really just expressions of the pain that the CISO and the CIO feel around the lack of integration across different teams and point solutions. Two, focus on the hygiene components of your architecture and be conscious of where you have weakness in your posture from things like a configuration perspective. And that's where things like pentesting can be super, super helpful. And then the third one is take a sober approach to machine learning. Crawl, walk, run. These are the things, and really focus on the use cases that matter for you as an organization. Behavioral analytics, insider risk, these are things that we say all the time. The truth is, every organization may have a slightly different crawl, walk, run journey, or should have a slightly different crawl, walk, run journey towards maturity in things like insider risk, depending on what use cases are most relevant to them. So I'll pause there.
Yeah, no, that's really great, especially teeing it up. If you go to so let's talk about the next story. I've got 5 of these stories and a few others. So the second story here is I thought we patched that, and this was absolutely incredible. So 10,000 hosts, This healthcare facility had probably one of the best patching disciplines and methodologies I had seen as a practitioner. They took patching very seriously. Once again, did all the right things. They had their vulnerability management program in place, their AV program in place. So initiate a pen test. We immediately find, or NodeZero immediately finds a domain controller. And from the domain controller, we successfully exploited zero logon to become domain admin. So for those that aren't aware, zero logon came out in 2020. Absolutely devastating CVE, 10 out of 10 criticality, because in a single line in command, an attacker can immediately become domain admin on the box. And so once an attacker has domain admin, they've got keys to the kingdom. So when the customer saw the path, proof, and impact for zero logon exploitation, they said, nope, absolutely not. This isn't possible. Qualys and Microsoft are both reporting that domain controller is patched successfully. So there is no way that you guys exploited it. And sure enough, within the product, we'll actually surface the command that it was executed. And they copied and pasted the command and got admin on the box. So what happened? Well, zero logon, the patch itself has 2 steps. Step 1 is to update the registry files on that box to show that the patch was applied. And then step 2 is to apply the binaries. Cylance blocked the binaries from being applied. So the registry had been updated, but the binaries never actually got swapped out. Qualys only relies on the registry. They don't actually exploit. And so as a result, this healthcare company went 18 months with this issue unnoticed. And because it was so easy to exploit, they had no confidence that an attacker had not already burrowed in the environment. So they had to tear down and rebuild their entire network. So therefore, in addition to Patch Tuesday, they now have Pen Test Wednesday. And the key part here is you've got to assume the attacker is going to get in. They're going to gain initial access. And if you assume they're going to gain initial access, focus on detecting the privilege escalation and the lateral movement, because they had to rebuild the network, because once the attacker gained initial access, they didn't see anything in their logs within their security infrastructure. And so understanding what your logging blind spots are, can you detect, can you not detect, and so on, becomes super important. And so Patrick, maybe some quick commentary on these types of issues that you'll see, which is assume initial access, what is that lateral movement and privilege escalation, and some thoughts on things customers can do there.
Yeah, I mean, look, I think the assets and identities, sort of speaking in Splunk speak, Snehal, and you're
Yep.
probably familiar with this, is such a massive challenge, but it requires such a significant investment. And again, I think this is where, we have to be careful that we don't let our penchant in security for the easy button, because of the amount of that security teams are under. I mean, you don't need me to walk through the pitch here, but the ever increasing amount of alerts, the lack of talent. We got the great resignation. I mean, security teams, people often forget, security teams, even on top of all of this, are going through the same challenges that all teams are going through, frankly, around retention of staff and attrition. And so, there's a lot of stress, and there's a push for the easy button here. And sometimes things like, zero trust are these sort of big button words like insider risk, where you think you can just have a easy button that will help protect us from this. But really what it comes down to is, do you have the right kind of patching and prioritization in place? And by the way, by right, I think that's a spectrum. And are you focused on what the process is around that? How well is that interlocked with your pen test and red teaming capabilities? Does your red teaming help drive prioritization in your patching? And I think that's a big question, because what we often see is you mature your red teaming and you overwhelm your vulnerability management, right? And so how do you help not just drive more visibility into vulnerabilities through your red teaming, but how do you help drive prioritization?
Yep.
And prioritization can come from pen testing, but can also come from having a really, really strong grasp of your assets and identities. And look, anybody who's ever built a security operations team knows, and I know you know, like CMDB and assets is really hard.
Yep.
It's still not a fully solved problem, and it requires investment. But there is no easy button for this, and I think this is where Horizon 3, having sort of the clear capabilities that you're outlining here, having strong logging and prioritization in case management, in CMDB, the basics, the stuff that you have to get to the next level of maturity, have to be in place before you go grasping for that easy button.
That's exactly right. And what you're going to see in a theme of all these is the fundamentals. Here's another one that's really interesting. Attackers don't have to hack in using 0 days like you see in the movies. Often they just log in. So this was, once again, an internal infrastructure pen test. This customer had an on-prem plus a 365 environment. So a common way attackers will compromise you is once they've gained initial access, they'll start to do man-in-the-middle relay type attacks and start collecting hashes. Tools like Responder are well known in the attacker community for grabbing those hashes. So we successfully grabbed a bunch of hashes. We then took those hashes and successfully cracked them into their clear text passwords. And then from there, now we've got a domain user, and we're able to successfully log in as domain user all over the place, including the 365 account, and got access to company emails. And this was across the board. What's amazing are the stats. Over 80%, it's actually more than 240, but 82% of the hashes that we collected were cracked in 15 minutes or less. Think about that. Most organizations have domain user is the local admin on a machine. So if we've got now 240 valid domain user logons, an attacker has access to every piece of data, every piece of infrastructure that domain user has access to. And they've got local admin on the machine, so they can start to dump credentials and pivot and iterate. 6% of the users had passwords based off the company name. 10% of their service accounts, so that Splunk admin type user ID password, or WebSphere admin, and so on. The user ID and the password were exactly the same. 26% of user accounts had some formula aligned to their passwords. And then what we also saw that was really interesting is the password reuse was very regional in nature. So like the Houston team had a particular formula for their passwords that was prevalent in Houston. The New York team admin team had a password formula unique to New York, like Go Yankees or Boston Sucks or whatever there might be, but they were very regional in nature. And these are the types of analytics that attackers are going to be able to figure out as they collect those hashes. So they don't need to compromise you using a CVE. Often they're going to collect those hashes, crack those passwords, and then log in as a valid user all over the place. And so back to privilege access management, identity hygiene that Patrick mentioned earlier, understanding and looking at user behavior analytics in a more intelligent manner to be able to catch this becomes important. But sometimes it's not the individual password. There's a systemic issue like this that you've got to go off and address. So as you run pen tests in Horizon 3, we're actually able to surface these types of analytics as we collect and crack hashes, so you can start to get those systemic risks under control. Patrick, any thoughts?
I mean, only that's super interesting. That I'm not sure I've seen that kind of analysis from a pen test provider in my career. Snehal, genuinely, I think that's very interesting. So you can kind of surface password dynamics or password creation dynamics and what kind of the vulnerabilities may be there. I think it's super interesting. And I think this is where behavioral analytics, the promise of behavioral analytics can be very effective. When you talk about establishing a baseline pattern of life around an identity, and then being able to look at when you depart from that identity, when that identity's activities and behavior start to depart from that baseline pattern of life, and you see geographic location anomalies, for example, in the logs, right? This is the promise of behavioral analytics. So I think combining robust pen testing, strong visibility into the password patterns that are happening, developing password hygiene, multi-factor authentication, and then layering on a strong SIM with strong ability to do some of these, I would say, important, not necessarily simple, but like geographic location anomaly detection and logins is a concrete, discrete package of work in a use case that can be executed by really organizations of all levels of maturity with the right level of tooling and right level of staff. And so I would like to see us spend more time as an industry going to that level 2 and level 3 level of detail below things like behavioral analytics and talk about, all right, what are the specific things like that can actually help our customers protect and defend against these types of scenarios that you're laying out.
Yeah, you're spot on. So the punchline here, right, is you've got user issues and you've got systemic policy issues, and that understanding your logins, especially for high-value domain users, and in addition to your service accounts and admins, becomes really important. Now, fourth out of 5 stories is this is a hybrid customer, so they had on-prem environment and AWS. So internal pen test, NodeZero immediately starts to recon. In this case, there were 2,000 hosts reachable from that particular subnet. Builds the cyber terrain map to start to do its attack pathing. And then from there, identifies that HP ILO, the integrated lights out server, is running within the infrastructure and is able to successfully exploit that with code execution to become admin. Now, HP ILO is HP ILO, you've got iDRAC from Dell and so on. A lot of these are odd operating systems that they run on, and so they're not usually monitored. You don't usually have a Splunk forwarder on an ILO server, for instance. Some people will get it to work through the HTTP event collector, but it's not a process or a service component that people often observe. And attackers know that, so they go for the blind spots. And these are also tough to patch just because of where they sit in the environment. But ILO stores all of its credentials in clear text. So once NodeZero got admin, is able to dump all the clear text credentials. It then logged in to a Windows machine as admin that was next door. And then from there, pilfered the file system and found a credentials file on a share drive that, once again, had domain user access. That credentials file turned out to be the admin AWS credentials file. And NodeZero automatically pivoted to become admin of their AWS VPC. What's amazing here is this bank was spending millions of dollars on security tools, yet not a single security alert was triggered throughout this attack. And now you double click on what happened. Well, because they don't observe the iDRAC server, there was no alerts. And after compromising, the ILO server, after the ILO server was compromised, everything thereafter was a valid login and credential pivoting. So step 1 is patch and improve that ILO server. Step 2 is delete that credentials file. It should never be on a shared drive to begin with. And then step 3 is to improve the observation and instrumentation of privileged access logon across the board. And by the way, you're going to see that as a very consistent theme of how to compromise environments, is once an attacker's gained initial access, it's all about finding ways to harvest credentials, whether it's getting a local admin on a machine, pilfering data off of a printer, and whatever else. But this was an amazing compromise. It took less than 2 hours to become both domain admin on-prem and AWS admin, and their SOC had no idea. And so thinking through how do you instrument and making sure you've got coverage of your ILO services, your iDRAC services, and so on becomes super important. And I think the HTTP event collector in particular is a phenomenal piece of tech out of Splunk that allows you to start instrumenting these processes that are otherwise difficult to instrument with other tools because they're weird or custom OSs. Patrick, any thoughts?
Look, I think you nailed it. I think this is a frightening scenario. I think the one thing I would just add to this is, even if you do have that visibility and in place, Snehal, one of the things that we see is these are all relatively, I mean, maybe not specifically the ones you got on this slide, but these can be relatively low level alerts if they're taken in as individual alerts. As an adversary or even a rogue user is moving laterally across your organization, often they trigger what appear to be sort of low level severity alerts. And one of the reasons why we see that being so successful is because those low level signals get lost in the sea of alerts. And so one of the things we've invested in at Splunk is risk-based alerting, which basically allows you to correlate across all of these different low signal alerts into a single notable event that then gets bubbled up based on a risk score that is configurable by the organization. And this really helps prevent, one, it helps reduce alert fatigue because it does the aggregation of these alerts into a single notable. And it also really helps you, I think, get efficiency in your detection and response. False positives go down. The focus of the human analyst team gets more targeted on the collection of low-level signals that really become the high-level risk to the organization.
Yep, exactly. And that's the other key thing is being able to, and I remember as we were thinking through and talking about risk-based scoring when I was at the CTO, it's such an important feature to be able to take lots of lower level noisy events that in aggregate become important because attackers make a low plus a low equal a high. And that aggregated risk alerting is one of the best ways to capture that low plus a low equals a high. So I'll tell you the final story, war story, and we'll talk through some other things. And this is more of a pattern that attackers take, and you'll see this consistently. So what they'll do, if I wanted to go compromise Splunk or United Airlines or whatever else, as an attacker, I'm going to go to LinkedIn or LinkedIn Sales Navigator and search for anyone that's a pilot that works at United Airlines. And there's about 7,000 pilots that have identified themselves on LinkedIn. From there, you can quickly figure out that their user ID or their corporate email at least is some first name, last initial at united.com. Cool, now I've got 7,000 potential user IDs. All it takes is one of those 7,000 people to have a weak password, whether it's a compromised password that I can pull off the dark web, or they reuse their Netflix password for their corporate email, or their password is password. And what I'm going to do is log in once across 7,000 user IDs. So I'm not going to trip any of their account lockout procedures. And out of the 7,000 login attempts, one of them is likely going to work. And once I've got that password sprayed to a domain user, most likely, most organizations have it set up this way, domain user is also the local admin on the box. Once I've got local admin, I can dump SAM and get that local hash of the password. I'm going to crack that password, reuse those credentials, and then start to repeat this as I log in and navigate across the organization. And then from there, eventually, I'm going to be able to dump LSAS and get a domain admin credential and compromise the domain. So when you look at this as a pattern, one, the password spraying isn't going to trigger alerts usually, and that I don't even need a vulnerability in order to exploit this. And if I do, I could use SMB signing not required or other very low score, low risk vulnerabilities in order to become a domain admin. And that really builds on Patrick's point of risk-based scoring and alerting to be able to catch these kinds of things. So why do these types of attacks succeed? Usually there's a poor password policy. Least access privileges are not properly implemented. Active Directory groups are too permissive, where domain users are also local admins. The antivirus, for a variety of reasons, whether it was unhooked by the attacker, it was misconfigured as we saw in a previous story, or it just doesn't work well, didn't catch the LSAS dump, and that the various defensive tools weren't configured right, and that critical services weren't patched. And here's what's amazing. In over nearly 10,000 pen tests, user behavior analytics tools that were deployed rarely detected our credential pivots and lateral movements, in part because their logging hygiene across the board, whether it was Exabeam or any of these other UBA products that were out there, a lot of these products fail to build the baseline needed to identify anomalies. So what Patrick's brought up earlier is super important. There's no AI easy button to be able to catch these things. It's about getting the fundamentals right and making sure you've got the fundamentals in place. You're logging what matters. And then once you've logged what matters, now you can start to identify anomalies. Another interesting observation was many of our customers use MSSPs. And in many cases, those MSSPs took hours. In fact, one very well-known brand name MSSP took 7 hours to detect and alert on our presence in the environment. And we were not stealthy. We were a bonfire in a public square, egregiously violating their SLAs for that particular account. And so don't trust that the MSSP has your back. Verify that they're able to detect and respond attacks, and continuously verify and hold them accountable. The same thing for your SOC. Just because you bought all the right tools that Gartner recommended doesn't mean you're secure. You've got to attack and verify your posture. And then finally, there's a really high-end bank, and it took us about 7 minutes and 19 seconds to go from unauthenticated user to domain admin. And not a single alert was triggered. In 7 minutes. In 7 minutes, can your defender detect the threat, characterize its risk to the organization, and get approval to execute some stifling action? The answer is maybe, if you're really good and have that muscle memory. But in a year, it'll take me a minute or less. Now, can your human detect and respond in a minute or less? And the answer is probably not. And the human is going to quickly become the bottleneck. So Patrick mentioned this earlier. Understanding and investing heavily in automation and automated response becomes incredibly important, but you've got to have the basics in place first. So I'm sure, Patrick, I've cited you a bunch of times. Take me home on this story, and then we'll dive into a few other things.
Oh, I love it. I'll just add it because I know time is important. The speed matters, right? And we just did some research in our surge team. That we looked at 100 different. If you take this to like a ransomware example, we did research on 100 different ransomware binaries, and we found that the mean time to encryption across all those different binaries was less than 60 minutes across the board. And so speed is incredibly relevant in these conversations, and we can talk about all the beautiful detection tools in the world, as you're saying here, and we can have the perfect ML algorithms. But at the end of the day, if you're running with an MSSP that does your tier 1 investigation, and they've got a 7-hour turnaround time, all these different points matter in terms of thinking about what you as an organization can actually conceivably achieve in terms of mean time to detection. Tools matter, people matter, your partners matter, and how you think about creating your own sort of SLAs and SLOs as a team around that have to include all the different parts of that really important jigsaw puzzle.
Yeah, spot on. And back to the audience, please use the Q&A box, ask questions, leave comments. Really want to make sure that we get you engaged and get some good positive vibes going in the discussion here. So a few others. One is Log4Shell, and as practitioners, we've all kind of looked at and understood what Log4Shell does. And here's what's amazing: that in all the pen tests we run, 20 to 25% of the internal networks that we've attacked are still we're still able to detect and exploit Log4Shell. And what that means is Log4Shell is going to be an enduring problem. And here's why it's so dangerous. That curl command, that's all that is necessary to become admin or to basically sideload and compromise well-entrenched products like Apache Tomcat, vCenter, Elasticsearch, and other Java-based applications. It doesn't even have to be Java-based if you do centralized logging and forwarding. And so what's really surprising is how pervasive and how enduring the Log4Shell problem is going to be, that 9 months later, we're still 20 to 25% of our pen tests are compromising and exploiting it. And then back to instrumentation, it's going to become very important to get the basics in place, because there are very simple ways for attackers to gain access, and you've got to assume the attacker is going to get in. So look that I'll kind of build on a few other things. When you look at kind of the way our pen testing algorithms work is we dynamically select how to compromise an environment based on what we've discovered. And the goal is to become a domain admin, compromise a host, compromise domain users, find ways to encrypt data, steal sensitive data, and so on. But when you look at the top 10 techniques that we ended up using to compromise environments, the first 9 have nothing to do with CVEs. And that's the reality. CVEs are, yes, a vector, but less than 2% of CVEs are actually used in a compromise. Oftentimes, it's some sort of credential collection, credential cracking, credential pivoting, and using that to become an admin and then compromising environments from that point on. So I'll leave this up for you to kind of read through, and you'll have the slides available for you. But I found it very insightful that organizations, and ourselves when I was at GE included, invested heavily in just standard vulnerability management programs. When I was at DoD, that's all DISA cared about asking us about was our kind of our CVE posture. But the attackers have adapted to not rely on CVEs to get in because they know that organizations are actively looking at and patching those CVEs. And instead, they're chaining together credentials from one place with misconfigurations and dangerous product defaults in another to take over an environment. A concrete example is, by default, vCenter backups are not encrypted. And so if an attacker finds vCenter, what they'll do is find the backup location, and there are specific vCenter MTD files where the admin credentials are parsable in the binaries. So you can actually, as an attacker, find the right MTD file, parse out the binary, and now you've got the admin credentials for the vCenter environment, and now start to log in as admin. There's a bad habit by signal officers and signal practitioners in the Army and elsewhere, where the VM notes section of a virtual image has the password for the VM. Well, those VM notes are not stored encrypted, and attackers know this, and they're able to go off and find the VMs that are unencrypted, find the note section, and pull out the passwords for those images, and then reuse those credentials across the board. So I'll pause here, and Patrick, love to get some commentary on these techniques and other things that you've seen. And what we'll do in the last say 10 to 15 minutes is roll through a little bit more on what do you do about it.
Yeah. No, I love it. I think this is pretty exhaustive. What I like about what you've done here is, we've seen double-digit increases in the number of organizations that are reporting actual breaches year over year for the last 3 years, and it's often we kind of in the zeitgeist we peg that on ransomware, which of course is like incredibly important and very top of mind. But what I like about what you have here is we're reminding the audience that the attack surface area, the vectors that matter, has to be more comprehensive than just thinking about ransomware scenarios.
Yeah, right on. So let's build on this. When you think about your defense in depth, you've got multiple security controls that you've purchased and integrated. And you've got that redundancy if a control fails. But the reality is that these security tools aren't designed to work together. So when you run a pen test, what you want to ask yourself is, did you detect NodeZero? Did you log NodeZero? Did you alert on NodeZero? And did you stop NodeZero? And when you think about how to do that, every single attacker command executed by NodeZero is available in an attacker log. So you can now see, at the bottom here, vCenter exploit at that time on that IP, how it aligns to MITRE attack. What you want to be able to do is go figure out, did your security tools catch this or not? And that becomes very important in using the attacker's perspective to improve your defensive security controls. And so the way we've tried to make this easier, back to like I bleed green in many ways still from my Splunk background, is you want to be able to, and what our customers do is, hey, we'll look at the attacker logs on one screen, and they'll look at what did Splunk see or miss in another screen. And then they'll use that to figure out what their logging blind spots are. And where that becomes really interesting is we've actually built out an integration into Splunk where there's a Splunk app you can download off of Splunk Base, and you'll get all of the pen test results right there in the Splunk console. And from that Splunk console, you're going to be able to see these are all the pen tests that were run. These are the issues that were found. So you can look at that particular pen test. Here are all of the weaknesses that were identified for that particular pen test and how they categorize out. For each of those weaknesses, you can click on any one of them that are critical in this case, and then we'll tell you for that weakness, and this is where the punchline comes in, so I'll pause the video here. For that weakness, these are the commands that were executed on these endpoints at this time, and then we'll actually query Splunk for that IP address or containing that IP, and these are the source types that surface any sort of activity. So what we try to do is help you as quickly and efficiently as possible identify the logging blind spots in your Splunk environment based on the attacker's perspective. So as this video kind of plays through, you can see it. Patrick, I'd love to get your thoughts, just seeing so many Splunk deployments and the effectiveness of those deployments and how this is going to help really elevate the effectiveness of all of your Splunk customers.
Yeah, I'm super excited about this. I mean, I think these kinds of purpose-built integrations, Snail, really move the needle for our customers. I mean, at the end of the day, when I think about the power of Splunk, I think about a product I was first introduced to 12 years ago that was an on-prem piece of software, and at the time sold on sort of perpetual and term licenses. But what made it special was that it could eat data at a speed that nothing else that I had ever seen. So you could ingest massively scalable amounts of data. It did cool things like schema on read, which facilitated that. There was this language called SPL that you could nerd out about. And you went to a conference once a year and you talked about all the cool things you were Splunking, right? But now as we think about the next phase of our growth, we live in a heterogeneous environment where our customers have so many different tools and data sources that are ever expanding. And as you look at the role of the CISO, it's mind-blowing to me the amount of sources, services, apps that are coming into the CISO span of, let's just call it span of influence in the last 3 years. We're seeing things like infrastructure, service level visibility, application performance monitoring, stuff that just never made sense for the security team to have visibility into, at least not at the size and scale which we're demanding today. And that's different. And this is why it's so important that we have these joint purpose-built integrations that really provide more prescription to our customers about how do they walk on that journey towards maturity. What does 0 to 1 look like? What does 1 to 2 look like? Whereas, 10 years ago, customers were happy with platforms. Today, they want integration, they want solutions, and they want to drive outcomes. And I think this is a great example of how together we are stepping to the evolving nature of the market and also the ever evolving nature of the threat landscape. And what I would say is the maturing needs of the customer in that environment.
Yeah, for sure. I think especially if we all anticipate budget pressure over the next 18 months due to the economy and elsewhere, while the security budgets are not going to I don't think they're going to get cut, they're not going to grow as fast. And there's a lot more pressure on organizations to extract more value from their existing investments, as well as extracting more value and more impact from their existing teams. And so security effectiveness, fierce prioritization, and automation, I think, become the 3 key themes of security over the next 18 months. So what I'll do very quickly is run through a few of the use cases. Every host that we identified in the pen test, we're able to score and say, this host allowed us to do something significant. Therefore, it's really critical. You should be increasing your logging here. Hey, these hosts down here, we couldn't really do anything as an attacker. So if you do have to make trade-offs, you can make some trade-offs of your logging resolution at the lower end in order to increase logging resolution on the upper end. So you've got that level of justification for where to increase or adjust your logging resolution. Another example is every host we've discovered as an attacker, we expose and you can export. And we want to make sure is every host we found as an attacker is being ingested from a Splunk standpoint. A big issue I had as a CIO and user of Splunk and other tools is I had no idea if there were rogue Raspberry Pis on the network or if a new box was installed and whether Splunk was installed on it or not. So now you can quickly start to correlate what hosts did we see and how does that reconcile with what you're logging from. Finally, or second to last use case here on the Splunk integration side is for every single problem we found, we give multiple options for how to fix it. This becomes a great way to prioritize what fix actions to automate in your SOAR platform. And what we want to get to eventually is being able to automatically trigger SOAR actions to fix well-known problems, like automatically invalidating passwords for poor passwords in our credentials, amongst a whole bunch of other things we could go off and do. And then finally, if there is a well-known kill chain or attack path, one of the things I really wish I could have done when I was a Splunk customer was take this type of kill chain that actually shows a path to domain admin that I'm sincerely worried about and use it as a glass table over which I could start to layer possible indicators of compromise. And now you've got a great starting point for glass tables and IOCs for actual kill chains that we know are exploitable in your environment. And that becomes some super cool integrations that we've got on the roadmap between us and the Splunk security side of the house. So what I'll leave with, actually, Patrick, before I do that, love to get your comments, and then I'll kind of leave with one last slide on this wartime security mindset, pending, assuming there's no other questions.
No, I love it. I mean, I think this kind of glass tables approach to how do you sort of visualize these workflows and then use things like SOAR and orchestration and automation to operationalize them is exactly where we see all of our customers going, and getting away from, I think, an over-engineered approach to SOAR where it has to be super technical heavy with Python programmers, and getting more to this visual view of workflow creation that really demystifies the power of automation and also democratizes it, so that you don't have to have these programming languages in your resume in order to start really moving the needle on workflow creation, policy enforcement, and ultimately driving automation coverage across more and more of the workflows that your team is seeing.
Yeah, I think that between us being able to visualize the actual kill chain or attack path, paired with, think of the SOAR market, I think going towards this no code, low code SOAR, configurable SOAR versus coded SOAR, that's going to really be a game changer in or giving security teams a force multiplier. So what I'll leave you with is this peacetime mindset of security no longer is sustainable. We really have to get out of checking the box and then waiting for the bad guys to show up to verify that security tools are working or not. And the reason why we've got to really do that quickly is there are over 1,000 companies that withdrew from the Russian economy over the past 9 months due to the Ukrainian war. You should expect every one of them to be punished by the Russians for leaving, and punished from a cyber standpoint. And this is no longer about financial extortion that is ransomware. This is about punishing and destroying companies. And you can punish any one of these companies by going after them directly or by going after their suppliers and their distributors. So suddenly your attack surface is no longer just your own enterprise. It's how you bring your goods to market, and it's how you get your goods created. Because while I may not be able to disrupt your ability to harvest fruit, if I can get those trucks stuck at the border, I can increase spoilage and have the same effect. And what we should expect to see is this idea of cyber-enabled economic warfare, where if we issue a sanction like banning the Russians from traveling, there is a cyber-enabled counterpunch, which is corrupt and destroy the American Airlines database. That is below the threshold of war. That's not going to trigger the 82nd Airborne to be mobilized, but it's going to achieve the right effect. Ban the sale of luxury goods, disrupt the supply chain and create shortages. Ban Russian oil and gas, attack refineries to call a 10x spike in gas prices 3 days before the election. This is the future. And therefore, I think what we have to do is shift towards a wartime mindset, which is don't trust your security posture, verify it. See yourself through the eyes of the attacker, build that incident response muscle memory, and drive better collaboration between the red and the blue teams, your suppliers and your distributors, and your information sharing organizations that you have in place. And what was really valuable for me as a Splunk customer was when a router crashes, at that moment, you don't know if it's due to an IT administration problem or an attacker. And what you want to have are different people asking different questions of the same data. And you want to have that integrated triage process of an IT lens to that problem, a security lens to that problem. And then from there, figuring out is this an IT workflow to execute or a security incident to execute? And you want to have all of that as an integrated team, integrated process, integrated technology stack. And this was something that I cared very deeply about as both a Splunk customer and a Splunk CTO, that I see time and time again across the board. So Patrick, I'll leave you with the last word in the final 3 minutes here, and I don't see any open questions. So please take us home.
Oh man, Snail, you think we spent hours and hours prepping for this together? That last 40 seconds of your talk track is probably one of the things I'm most passionate about in this industry right now. And I think NIST has done some really interesting work here around building cyber resilient organizations that has really, I think, helped the industry see that incidents can come from adverse conditions, stresses, performance taxations in the infrastructure, service, or app layer, and they can come from malicious compromises, insider threats, external threat actors. And the more that we look at this from the perspective of a broader cyber resilience mission in a wartime mindset, I think we're going to be much better off. And what you talk about with operationally minded ISACs, information sharing, intelligence sharing becomes so important in these wartime situations. And we know not all ISACs are created equal, but we're also seeing a lot of more ad hoc information sharing groups popping up. So look, I think you framed it really, really well. I love the concept of wartime mindset, and I like the idea of applying a cyber resilience lens. Like if you had one more layer on top of that bottom right cake, I think the IT lens and the security lens, they roll up to this concept of cyber resilience. And I think this has done some great work there for us.
Yeah, you're spot on, and that's gonna, I think, be the next terrain that you're gonna see vendors try to get after, but that I think Splunk is best positioned to win.
You got it. Thanks for having me. Really appreciated this.
No, this is great. Thank you all for your time. And Alex, back to you. And we'll have the recording out and available. And once again, thanks for your participation.
Awesome. I'd like to thank all of our participants as well as Snehal and Patrick for being with us today. We hope the information you received during this webinar has been helpful to you and your organization.